and good morning to all the very respected teachers, those who are joining this our online course conducted by Indian Institute of Remote Sensing, Dehradun, on space technology and space applications. So friends, today I will be speaking to you for another next 40 minutes or so on the use of one of the space technology, which is known as Earth observation technology, or commonly called as remote sensing technology, and for sustainable development. How this technology is being used in India for achieving the goals of sustainable development, and how these technologies which are grown in India, indigenously developed technology, or Atmanirbhar Bharat banane mein, how these technologies are going to play a very important role. So what you see here is a satellite which is there at around 500 kilometers from the surface of Earth. And this satellite talks to a ground station on Earth. So whatever, satellite images are captured at around 500 kilometers from Earth, they are transmitted by the satellite to this ground station through microwave, radiations. And once these, data comes from these ground stations, we store all this data at our, center here in NRSC. We have a beautiful data center which has satellite data of last 34 years, and this is how these satellite images looks like. But these are not photographs. They are being used for generating information on cyclones, on droughts, on forest fires, on floods, agriculture, water availability, which basically are going to meet various goals what has been described by United Nations as sustainable development goals, essentially to achieve goals of no poverty, zero hunger, and then good health for everyone, quality education, and various other aspects which are related to our well-being and prosperity on this planet Earth, which I have shown here in the center. So this is how this beautiful connection from satellites to the people living on this planet is there, and we will try to understand that how these type of data sets are driving this very important objective of developing India as a Viksit Bharat. So today, if we look at what kind of natural resources India has and what kind of emerging challenges are there in front of us for next 25 years. So as you know, India is the 7th largest country, but we have only 2.4% of the global land area. And we host, the largest population of the world, which is around 18% of the total population. So 18% of population and only 2.4% of global land area is there with us. But our land is highly productive. We have different, agroclimatic zones. We have around 142 million hectares net zone area. We have per capita land is around 1.2 hectares, which every year it is reducing because our population is increasing. We have around 110 centimeters of average rainfall. Our coastline is around more than 8 to 9,000 kilometers. We have around 72 million hectares area under forest cover, which is of the order of 22% of our total geographical area. We have around 12 major rivers in this country which are providing water, to the people of this great nation. As far as human resources concerned, we have around 1.4 billion people, but it's not about only people. We have good amount of biodiversity. We have good fauna, flora, the wildlife, the domestic animals, which also need water. And then in terms of economic growth, year after year, we are achieving around 6 to 8%, economic growth. And, the total GDP contribution for agriculture is around 15%, industry is around 25%. India is a service dominated economy. So 60% of our GDP is coming from services. But if you look into future and do some crystal ball gauging, by 2040 or so, or 2047 or so, we will be around 1.6 billion people, in this country. This is a conservative estimate. It can be more than that also. And 50% of our population is going to get shifted towards urban areas. So there will be migration from rural areas to urban areas. The food grain demand will be around 345 million tons, which is around 248 million tons now by 2030. The water, and especially we are very much dependent on rain as well as groundwater resources, where we know that groundwater is depleting very fast. In some of the areas, if we don't take precautions and we don't take corrective action, groundwater depletion will continue to happen. Another global threat which is also looming on us is the temperature rise because of the greenhouse gas increase in the atmosphere. So already we have recorded around 1.2 degrees Celsius temperature rise in continental parts of the country, around 3 degrees in the Himalayan region, and we expect that this trend will continue. Already you are seeing how much heat is there this year. Many cities are suffering because of the heat wave conditions, but situation is not going to improve as the time passes. Probably we have to take action to contain this temperature rise up to 1.5 degrees Celsius. This high temperature increase will also lead to the warming of the oceans, and this warming of ocean will lead to the sea level rise. And it is expected that by 2040 or so, the sea level will be almost double what it is today. And then some of our coastal areas may also get inundated and some land loss may occur. Every year, disasters are also increasing, extreme weather patterns are increasing. Last year, we have extensive floods. Even in Punjab, we had very bad floods in Jammu and Kashmir, in Himachal. There were extensive flooding episodes which has devastated properties. It is likely to continue, and we need to learn now to live with this changing climate and evolve what we call as the climate action plan. So if we have to tackle all these challenges in next 25 years or so, what should be the national priorities? We have to, since the population is going to increase, the food demand will be more, land area is limited, and then some of the land, agricultural land is also getting converted into urban, land uses. We have to think of enhancing agriculture production, as well as water still is an issue. Already we are facing water crisis in many of the Indian cities. So availability of the groundwater as well as the potable water has to be ensured for the entire population. We have large amount of our land is getting degraded, and then we have to minimize this land degradation. We have to have conservation of bio resources, improve the weather forecast, as well as the forecasting capability for the extreme weather event. We have to generate, we have to have infrastructure which is disaster resilient. That means we should be in a position to cater to any adverse effect of any disaster on our infrastructure. India has already made commitments in global forums that we will cut our emissions to and will become a net zero emission country by 2070. So that means that at least by 2030, we have to cut our reductions by 43% and move towards cleaner and greener energy resources. Today, you all cannot live and think life without connectivity. So earlier it used to be a slogan in India, roti, kapda or makan, but today it is roti, kapda, makan and internet. Without internet, many of us cannot live even for a few minutes today. So connectivity, and that to high bandwidth connectivity to all, even in the rural areas as well as, far-flung area of India, last mile connectivity has to be ensured so that, benefits of the economic development can reach to the people living in the rural areas. So in overall, we need to have a better understanding of the earth as a system and also develop strategies to combat climate change. Now, to do these things, a lot of action is required, a lot of data is required to understand, to bring out information, knowledge, and decision making. And many of these data sets basically will lead, for the goal of sustainable development. People are talking that we should have development, but it should not be a development that we do not leave resources for the future generation. And, the development should be done in basically what we call as the sustainable manner. So what is sustainable development? Sustainable development is the development that meets the need of the present without compromising the ability of future generations to meet their own needs. If we are depleting the entire groundwater resources, maybe in next 5 to 10 years, then what future we are going to leave for our generations to come? We need to ponder about those aspects. If we are going to take up all forest resources, if we are going to exhaust all water resources, what will be the future for our future generations? How they will survive on this planet Earth? So we have to develop strategies which basically ensures development, but by retaining the environmental sustainability. And to achieve these goals, as I told earlier, United Nations has come out, what is known as the 17 Sustainable Development Goals, and these goals are to be met by the member states by 2030. The important ones are basically that we would not have, poverty. We will alleviate poverty. We will have zero hunger. We will have good health. We will provide quality education. We will have gender equality. We will ensure clean and water sanitation, and then also green and clean energy systems, decent work and economic growth. There are so many such sustainable development goals which has been postulated. So to meet some of these objectives, the space technology also plays a very important role, especially the Earth observation data based directly addresses almost 17 sustainable development goals, focusing on the two main pillars of environment and economic growth, as well as to derive climate action, life on land, and responsible consumption and production. Another technology which is known as the global navigations, support systems or space systems, GNSS, or commonly as GPS, or in case of our own constellation Navig, it also integrates and accelerate all the three pillars of sustainable development: economic growth, social inclusion, environmental stability, and basically helps providing services for industrial growth, infrastructure development, and sustainable cities. So to address the socio-economic security, sustainable development, disaster risk reduction, and governance, role of both Earth observation, GNSS, as well as satellite communication is very, very important. Now, since this lecture is mainly on Earth observation, we are going to talk more about how Earth observation data tells you about the health of the planet. Now, Earth is a living planet with changing surface and changing climate. And if we have to understand this at a planetary scale, cannot be a better tool than satellites. See, what you see here is the global, biological changes on Earth's surface, especially the productivity over the land, as well as productivity in the ocean in different seasons. Essentially, all our resources comes from the Earth itself. Mostly they come from the biological sources like plants, as well as minerals from the geological part of the Earth. Then oceans also provide you large amount of food availability. So the amount of the productivity happens on Earth, on terrestrial areas, or let's say continents. Same amount of productivity also happens in the oceans, and oceans are also rich source of biological productivity for fisheries, higher level biological animals in the oceans, as well as sequestration of carbon dioxide into the ocean columns. So today, using this satellite data, we can get vital information about atmosphere, about biological resources like forest, loss of species, loss of critical habitats. Snow and glaciers are very important, especially in India. Himalayan region is the abode of snow and glacier, and all the North Indian rivers, they get their water by melting of the snow and glaciers. If these ecosystems are affected, the water availability will also be under question. Oceans, as I told, covers almost 70% of the geographical area, and they control the climate of this planet. So we need to understand oceans very critically. And of course, about our physical resources, land dynamics, water availability, soil degradation, biodiversity losses, all these issues which basically governs food security, water security, disaster resilience, and then social and our health also is linked because we are living in this environment. All this can be, can be of great importance when we start providing data from satellite-based sensors. So today, India, as you are aware, we run almost, the fifth largest space program in the world is basically coming from ISRO, or Indian Space Research Organization. We also operate a fleet of remote sensing satellites. So we have, four categories of remote sensing satellites. One is called Natural Resource Inventory and Disaster Management, where we have resource set 2, 2A, and RISAT class of satellite. RISAT is a microwave satellite which basically can see through clouds, provide day and night data of our surface. Then we have, large scale mapping infrastructure and planning cartographic satellites. So we have this very high resolution satellite series, Cartosat 2S, as well as Cartosat 3 series of satellites. Oceans also we are studying with our OceanSat 3, with Saral satellite, as well as, having sensors like scatterometer and ocean color monitor. Then weather and climate is also very important to keep eye on the evolving weather patterns over India. We have launched now 3 satellites called INSAT 3D, 3DR, and 3DS, which basically provides, the detailed information about the weather patterns at around 15 minutes interval over the different parts of the country. So all the satellite data with different revisit capability, with different kind of data, is basically today being used for various applications. And all this data now is freely available through our Bhunidhi data portal of NRSC as per the new, space policy of Government of India. All the people, everyone, even in schools, you can encourage students to download some of the satellite images. So this is how the satellite looks like. This is one of the India satellite called Cartosat series of satellite. This satellite provides very high resolution data. They have this big telescope, around 1.2 meter telescope, and then back-end electronics. And this is how, the entire satellite looks like. This is of the size of an SUV car, which is having, a weight of around 1,000 to 1,200 kilograms or so. So these satellites are lifted by the rockets, and I am sure that there was you must have been given some flavor about our space transportation systems. We have this PSLV and GSLV class of, rocket launchers which carry these satellites into space, and once they are established into space, they start providing this type of, wonderful images. So as you can see here, this is an image over New Delhi. Here you can see the Rashtrapati Bhavan. Then this is the Kartabya Path, or earlier used to be called Rajpath. Both the sides you have North Block and South Block. And this is the India's Parliament, the old Parliament, and the new Parliament building. You can see very clearly using these satellite imageries. In fact, you can also see some of the cars on the road, as well as some new construction, which is basically our Central Vista building. A new secretariat for government staff is being constructed. And the resolution of the image is so high that you can see individual trees and their canopies all around the Rashtrapati Bhavan over here in New Delhi. So this is the kind of outcome from these satellites, which basically goes into the space. There is another image of one of our high resolution imaging satellite called Cartosat 3 around the border. So this is basically Uttarakhand border. You are sitting somewhere here in Dehradun, just a few hundred kilometers away into Tibet, which is now being controlled by China. We have a place called Chanda County. Many people think that Tibet is a very high altitude, dry, barren land. Nothing is happening over there, but that's not correct. Chinese are changing the landscape of Tibet. And around Chanda County, you can see the kind of development which is being done by Chinese in this area. Even there are, massive football ground infrastructure. There are other, infrastructures are coming up in this area. Chinese have a passion of, showing their dominance by imprinting their slogans on mountains. So as you can see here, over here, there is a imprint of their, their Chinese language, which we can clearly read from the space also. This they have demarcated on the hill slopes here in Jhanda County. So this is the kind of activities that are happening in the Tibet region. So not only for within the country, we have capability to find out what is our happening in our neighborhood across areas using this type of wonderful satellite systems which are developed in our country. Not only these two-dimensional images, we can also provide information about the third dimension. That means the topographic variations using a method called cartography or photogrammetry. So we have launched this cartographic satellite called CartoSat-DEM. It has two camera systems separated by some distance like our eyes. This is called parallax. So using this parallax, looking, both the cameras, they look at the same place from two different angles. And by doing a mathematical modeling of, photogrammetric techniques, we can generate this height information. And for entire India, this full-fledged Carto digital elevation model has been generated. And we also have, aircrafts and UAVs, which can give you very high resolution topographic information from other platforms also. So I'll show you one example that how we are using this topographic data to visualize the terrain. So now you are basically going to now Gangotri. This is Bhagirathi River, and this is the Gomukh Glacier. From where the Ganga originates, you can see, and then above this, the water is stored in the solid ice form in this glacier. This glacier is a very long glacier, around 23-kilometer long glacier. And, with this type of fly-throughs, you can create these digital simulations in your lab for entire terrain. And then see the terrain features sitting in the lab before you try to, go even to the field and try to do any expedition. You get a fairly good idea about the terrain sitting at your home itself. So this is the kind of advantage of this type of third dimensional or the 3D maps today, which are available from satellite-based observations. So these photographs which I showed you, images, they are not only beautiful images. Once you put them into a system, you do time series analysis, you do multi-date analysis, you do, these images are in different parts of electromagnetic spectrum in different wavelengths. By analyzing this data in different scales and from different sources and combining it with the ground information, you can generate up-to-date maps, you can create management plans for ecosystems, you can do multi-criteria analytical modeling for deriving meaningful results. And then, all these things can lead to data-driven decision-making for long-term sustainable development. So I will show you some examples for food security, water security, energy security in this presentation, that how our scientists are converting these data sets into information and knowledge. One of the important, application of all this data is basically towards achieving food security. So we have a program called Fasal program, which basically is, supported by Ministry of Agriculture and Farmers Welfare, where for around 11 crops now, pre-harvest crop production estimates are provided for rice, wheat, mustard, sugarcane, cotton, sorghum, jute, pulses, and groundnut, maize, pearl millet. Many such crops have been added, and you get an early assessment that at national level, how much area is there in season for these different crops. Not only crop area, we can also convert using some agrometeorological data, this information into the crop production. Another important aspect is basically about our horticulture crops. See, India is also the second largest producer of fruits in the world. Many of we don't realize that from where this fruit comes. They come from orchard systems. Where are these orchards in the country? There is no inventory available. So ministry has now done and come with the space department to use high resolution satellite images to generate the first time inventory of mango orchards, banana orchards, citrus orchards, potato grown area, onion, tomato, and chilies. All these are now geographically marked, and their production zones and their catchment areas are very nicely delineated for planning, the expansion plans, as well as for food processing facilities like cold storage or juice extraction, or developing industries around horticulture crops. So such kind of initiatives are being taken up. We have large amount of our geographical area under wastelands or degraded lands, of different types. So many of the action plans of the government of India are now towards reclaiming and bringing more area under agriculture so that we can, cater to the increasing food demand as our population is increasing. Then similarly, we are also doing crop intensification, like pulses. We have to import pulses. So we can identify land parcels which will remain fallow, during two crops, and then short duration pulse crops can be, done in those areas. So such type of patches has been identified in the eastern India as well as in Madhya Pradesh, and now the sustainable pulse, production has increased in India, which is basically leading to stabilization of pulse prices in India. Otherwise, you must have come across few years back, suddenly the pulse prices became double or almost 2.5 times. So these interventions using space technology by Government of India as well as Department of Space have been very fruitful on the ground to control the economic prices of some of the major crops which are consumed by the citizens of this country. Today, there is a program called Yield Estimation System Based on Technology, or YesTech program. Basically, this is aimed towards providing crop insurance support for the farmers at the panchayat level and the insurance level. So using satellite technology for major crop growing states in India, we are generating assessment of crop damages due to various reasons, either due to drought or because of extreme rainfall event or pest and disease infestations. The panchayat level, at insurance level, the data is being produced about the crop losses, and this is now being used by various insurance companies to do settlements and assessment of the claims of farmers in case of crop losses because of various either natural or because of some other events. So this is the kind of penetration of satellite technology which has happened at the national scale today. Water, food, after food, what is important? Water is most important. Even water is important to grow the food. Now we have almost 4,000 billion cubic meter of precipitation in the country. 40 to 70% of this basically gets evaporated because of the radiation related issues. So we are basically having around 1,123 billion cubic meter usable water with us. And we have around 68 million hectares net irrigated area. 60% of the area is getting irrigated through groundwater. Many of you are coming from the rural areas, sub-rural areas. Many of you must have seen कि वही borewell लगा दिया, borewell लगा के water extract करके irrigation होता है इंडिया में. So this basically leads to low economic power per water productivity. For large amount of water use, the efficiency of water use is very, very less. So we are over exploiting the water for irrigation purpose today. That is the reality. So we are using, satellite technology to provide estimates of surface water availability, groundwater prospect zones, budgeting and sustainability of water, command area development, irrigation assessment. Reservoirs are basically getting their capacities reducing time by time because of sedimentation into the reservoir. So that reservoir capacity evaluation is also being done by NRSC and other ISRO institutions on a systematic basis. We have come out with a concept called surface water availability assessment. Major reservoirs, every 15 days we are producing water maps. How much amount of water is available in major reservoirs of India? That information is available in dashboard form for major reservoirs, medium reservoirs, and small satellite bodies. Similarly, in different watershed areas, assessment for irrigation potential is being assessed. Irrigation scheduling, outlooks are being planned, and then using space technology and the geophysical groundwater assessment systems, the prospect and sustainability of the groundwater is also ensured today in the country. This is one example, especially in case of Rajasthan, where there are large issues related to the water availability. Using satellite data and the geophysical technology, we have, given water, the availability of, which area one should go for doing bore wells. So in Rajasthan, especially in desert area, there are a lot of channels which are known as paleo channels, where earlier in historical past river used to flow. Using satellite data, you can find out signatures of these paleo channels because they contain more moisture compared to surroundings. So this is one such paleo channel which appears much greener because of the sparse vegetation over here. And this paleo channel was identified, and then in this area around some village, using geophysical technology, we have done the sampling in this area and find out at what level, at what depth the potable water is available for the farmers or for the village folks. And based on this analysis, precise location of bore wells to be dug was identified, and the villagers of Upni village in Bikaner, they got benefited by very good quality water by combining satellite technology and other geophysical technology in this area. This is one such example. Many such case studies has been done in last 10 to 15 years across the country by various ISRO as well as other science and technology organizations of this country. Then we are running this what we call as the National Hydrology project which is supported by Ministry of Jal Shakti. So this is providing information about glacial lakes. Lakes are forming in abundance in the Himalayan region because of the climate change. The snow which falls in Himalaya, how it melts and how much water it produces. During the monsoon season, floods becomes very abundant in India, both riverine floods as well as flash floods. We are providing flood early warnings. We are also basically making a lot of modeling efforts towards generating products for drought assessment as well as decision support systems. I will talk some examples in the subsequent slide. This is an example of a lake in Sikkim at the mouth of a glacier called the South Lonak Lake in Sikkim area. You can see this is a glacier, and the glacier has melted away and left a big lake which has formed, and which is the size of the lake has increased 3 times in last 3 decades because of the melting of the the ice in the glacier. Now at some point of time, these lakes become so large that if any event happens. So on 4th of October, one event happened when the snow avalanche or ice avalanche happened, and then that material has fallen into the lake. You can see on 28th September, the lake area was around 167 hectares. And then on 4th October, we got a satellite image. Half of the lake is filled with the debris. And this debris, which has fallen into the lake, caused a massive flood downstream because all this water basically, has penetrated and infiltrated into this river path. And the flood was so, the flash flood was so massive that more than 200 people, especially the army people who were sleeping in the night and have in their camps, they all got washed away. One of the hydropower plant in this area totally got devastated. Such a huge amount of water got spilled through this lake in very short period of time, in few hours. So such type of events are increasing in the Himalaya, which are affecting the lives of the people in the downward areas. And these events are called GLOF events, glacial lake outburst flooding. So we have now estimated, how many such lakes are there in the country. We are now doing risk assessment around the most vulnerable lakes in different states, Himalayan states, and a national program has been taken up by NDMA, National Disaster Management Authority, for tackling this GLOF risk assessment events across the country after the South Lonak Lake. Another important aspect is the energy availability. As our country is growing with 8% growth, the energy demand is also increasing. And as per our, commitments for Paris Convention, we need to cut our emissions and reduce, dependency on hydrocarbon deposits. That means less amount of burning of coal, less amount of utilization of petrol, diesel, for achieving the energy security. So India has taken very important initiatives towards moving and doing transition on to renewable energy. and large amount of solar parks, almost 57 solar parks has come up in the country, and our target is to achieve around 500 gigawatts of our energy requirement to come from the alternate sources. So using satellite data, we have mapped the hot spots where the sun energy is abundant throughout the year, and come out with assured annual solar energy atlas. So what you see here in the deep blue color are the areas where more than 2,500 kilowatt hours per meter square per year of solar energy is available. So states like Gujarat, Rajasthan, Madhya Pradesh, Maharashtra, Telangana, parts of Karnataka, Chhattisgarh, these are the hotspot areas where assured solar energy is available throughout the year, compared to states like Uttarakhand or the northeastern part where cloud cover is much more, during certain periods. So these areas becomes, the most ideal and suitable location for generating these solar parks, etc. So we are providing support to this industry by doing, solar forecasting, solar energy forecasting, as well as also providing products for wind energy potential in the offshore regions for generating winds energy in the coastal areas of the India. This is how some of these large solar power plants looks like, and we can capture them from space also. This is one big solar power plant called Badala Solar Park in Rajasthan. This has around 56 square kilometer area. This is spread in 56 square kilometer area on wasteland. Most of the area were desert in this case, and then in between you can see some farms also. But this is likely to produce now 2,200 megawatt power, on a sustained manner. So many such type of initiatives of providing clean and green energy to the countrymen are now being taken up. Another very important aspect is our forest cover. Every 2 years we are mapping our forest cover, which is called as the biennial forest cover mapping by Forest Survey of India. Satellite data basically is the most important source for producing this information. So as per 2021, now 23 data is also available, where our 22% of our total geographical area is under forest cover. Both, the notified forest as well as trees outside the forest are included in this. We are also doing the biological richness of Himalayas. We are basically trying to make assessment of different vegetation types, different species, and then also identify the areas which are basically called as the disturbed areas, and assessing the biodiversity of the country. One of the threat of the climate change is also depletion of the biodiversity. So such kind of baseline databases are very important at national level, so that we can account the loss of the biodiversity as the temperature increase likely to happen in future years. We are also working extensively towards achieving sustainable cities and villages by providing the master plans for different cities. Almost 500 cities were identified in the Amrit scheme of Government of India at 1:4,000. 4,000 scale databases were prepared by NRSC, and which basically provide details of land use and land cover for generating the master plans. We are also working extensively on urban water body information system, as well as generating baseline data for entire country at 1:10,000 scale for ortho images, assets, themes for almost 6,50,000 villages. There are around 7 lakh villages in the country, and 250,000 panchayats. This data will be very, very useful for activity planning, monitoring of programs and schemes at Gram Panchayat level development. This is likely to be released very soon, I think next week itself, by the Government of India at New Delhi. There will be a specific talk after my talk in the afternoon on disaster risk reduction. So I will not go into details of it, but today I can tell you that we are using various satellite technologies in different phases of disaster management, in preparedness, in early warning, and then in providing near real-time services during the disaster, as well as for reconstruction and recovery purposes also. Satellite images are being extensively utilized. This is one such example where we are providing near real-time flood maps especially for the flood affected areas. So this is one such map. This is how these blue areas are the flood inundation areas in Punjab last year during the flood season. And this is how these floods are delineated onto the satellite images. And the cumulative flood map of Punjab from 11 July to 2000 August after the flood season is over is also produced so that it can remain as a historic record. So all these red areas are essentially the areas which got affected by extensive floods in Punjab last year, especially between 11 July to August 2 during 2023. So large amount of database, last 25 years of flood occurrence database we have in the country, and we have created flood hazard atlases. We are also enabling large amount of G-governance, initiatives of Government of India, especially Ministry of Rural Development have this Manrega program, rural roads and housing programs, watershed development programs. Their geotagging is being done. That means geotagging means you take the ground photographs which are basically having the coordinates of that particular location. And then all this data comes to a web portal, so government can keep a track that what kind of activities are being done, under these different schemes. And then they can also do monitoring and progress assessment of such developmental activities which are being enabled through various ministries of Government of India. Climate change and its induced impact, I think it will be talked in detail in the afternoon talk, but I will only say that today, using satellite technology, we can monitor the agents of climate change. That means we can make measurements of greenhouse gases. We can make assessment of which areas the biomass is burning, especially, country areas like Punjab, Haryana, a lot of biomass burning happens after the Kharif crop production. Then we can also, find out the sources of pollution, both at terrestrial as well as ocean areas. There are a lot of ecosystems which are basically getting affected by the increasing temperatures of the land, especially the glaciers are retreating, polar ice covers both in North Pole and South Pole is declining, alpine zones are enhancing, coral reefs are under stress, desertification processes are also on rise. So all these processes which are basically getting affected, or ecosystems which are getting affected, are essentially getting captured, and then we are also generating some forecast for using modeling approaches that what will happen to this ecosystem if climate change continues to remain with the current speed. So all this information is basically getting generated under a program called National Information System for Climate and Environmental Studies, or NICIS. So some of you can visit this NICIS website and you can find large amount of these databases on various aspects of climatic variability. This is one beautiful, animation which is recently generated at NRSC, where at global level you can make measurement, you can see how the vegetation dynamics happens, on a global scale in different months. So when you are in the winter, there is nothing is growing in the Europe, but when the summer starts happening, by June or July, the entire northern territories, they become green. Same way, the oceans also, the greenness of the ocean basically indicates high productivity in the ocean. Those areas in the deep blue essentially are the ocean deserts. Nothing grows in these regions, but wherever you see the green and red color in ocean, large amount of fish production happens in these areas. So you can delineate the areas where high productivity of the marine organism happens using this type of satellite images. You can also see where are the global deserts, like Sahara deserts, Namibia deserts, desert of Australia, deserts Atacama, Peru, deserts of South America, and some of the desert systems, especially California, Texas, in US also, can be delineated very beautifully by these global animations, which are produced by our own OceanSat-3 satellites, which is providing this data on daily basis. We are also able to generate wind information at a global scale using our scatterometer sensor, and these are some of the global wind information. So wind basically drives the climate of this planet. It controls the cloud systems, water vapor availability in the atmosphere, and also the wind power density is basically generated to find out areas where maximum impact of winds happens, and then wind power can be generated in these regions. We are also using this information of ocean productivity in terms of phytoplankton or phytoplankton dynamics, sea surface temperature, etc., and some other parameters like wind, etc., to generate information about the potential fishing zone or fishing zone advisories for fishermen. So, a center here in Hyderabad called INQUIS is providing this information in the local language to all the maritime states of the country. And the data suggests that the fish catch per unit effort has increased by 2 to 4 times. Their search for the fish has reduced by 60 to 70% times, which is basically leading to the saving of fuels and has improved the welfare of the community for better livelihood. Now we are also combining the NAVIC technology or the navigation technology along with the Earth observation technology to provide all this information through a mobile app to the fishermen. They can get this PFZ information. They can know their location in the ocean. They also can provide any alerts if they are caught in the rough weather in the ocean, as well as if they are approaching international, boundary. Especially in case of Pakistan and India around Gujarat coast, many of our fishermen are being caught by the adversary. So once they approach this area, this particular app will give an alarm to them, and then they are warned that if they are venturing into the adversary's maritime water, they can have caution and exercise that caution and not to venture into that area. Otherwise, there is risk of being caught. So all this system is now has been put up in Kerala and Tamil Nadu. More than 9,000 boats have been fitted by vessel monitoring system and has been provided, fishermen has been provided this mobile apps. That it is expected then in the coming months, entire, the coastal fishing community, around 10 lakh fishermen probably will get this type of systems by the help of private sector and ISRO institutions. Another important aspect is basically the use of our meteorological satellites for providing very high resolution information on evolving weather patterns. So today we have these three satellites, INSET 3D, 3DS, 3DR, which provides every 15 minutes the weather patterns over India. This data is now being used to produce 30 atmospheric products and ocean products, which basically goes into numerical weather forecasting by IMD. A few years back, many of you, whenever IMD says that it will rain, you people were saying that it won't rain at all. But that perception has changed. Our weather forecast has considerably improved. And this is basically thanks to large amount of, observations coming from ground, which basically has been enhanced by IMD. And then, of course, lot of data getting assimilated from satellite-based systems into weather forecast has improved the skill of our weather forecast considerably. So that is also providing a lot of goodwill amongst the countrymen, as well as large amount of actions which are basically weather specific can be taken in advance. So in nutshell, these are some of the examples how the satellite technology is basically helping the citizens in terms of various livelihood scenarios, various resource assessment scenarios. We are now committed to provide and the continuity of these services, and we are now going to build new series of satellite systems called ResourceSat 3S and 3A series of satellite, which will augment the current fleet of satellites which are there in the sky. We are also developing the advanced microwave satellites called RadarSat 1B and NASA ISRO synthetic aperture radar, which is going to be launched probably next month. And then also developing some very advanced temperature mapping satellites along with the help of French scientists. This mission is called Trishna. All this data will basically further augment our capability to provide various services and to understand various ecosystems on this earth. So to summarize, I can say that as India steers towards its vision of becoming a developed nation by 2047, the role of geospatial technology is paramount in building, the capabilities of a nation which is front ranking in research, developing advanced systems for innovative technologies, improving throughput, low latency of delivery of services, All of these services are today being provided our Bhuvan and various other portals of ISRO. We have made institutional arrangements to adopt this application into national development programs, and we are also now encouraging lot of entrepreneurship. The government of India has come out with new space policy 2023. They have the space as a sector has been opened up for private sector participation, including launch vehicle development, satellite development, application businesses. More than 200 startup companies have come up in last 3 years in the broad domain of space technology and space applications, which is basically leading to business development, job creation, and overall societal welfare. So, in summary, I can say that space technology is touching lives of all spheres in the country, be it a farmer, be it a fisherman, or a person, which is trapped in disaster scenario. And I am sure that with you people, especially our teachers in the school, you will also encourage our students, the next generation, to read and to develop some ideas around what we talk today, to make this country a powerful country, as well as a country which is driven by the scientific passion and technological perspective. With these words, I would like to thank each one of you for sparing your valuable time and providing me this opportunity. I would like to thank IIRS so that today I could share some of my ideas and thoughts on these topics with all of you, our important partners in education, the school teachers.